Huawei is one of the world's leading technology companies, headquartered in China and known for its innovations in telecommunications, cloud computing, and AI infrastructure. Over the past several years, Huawei has faced sweeping sanctions from the United States, including restrictions on chip access and global partnerships, measures widely viewed as politically motivated and lacking transparent justification. Yet despite these headwinds, Huawei has continued to invest heavily in foundational technologies. At Huawei Connect 2025, the company unveiled a bold roadmap for AI infrastructure, including its Ascend chip series, Supernode architecture, and a new open-source interconnect protocol called Linku 2.0. These announcements signal not just resilience, but a strategic pivot, from competing in single-chip performance to redefining system-level computing. This dialogue explores the key takeaways from HC 2025, how Huawei is building scalable, intelligent infrastructure, proving its capabilities across industries like finance, education, and telecom, and laying the groundwork for a new era of digital transformation.
If you've been watching the global race for computing supremacy, the recent Huawei Connect conference 2025 felt, well, less like just another update and more like a roadmap for the next 5 years of AI infrastructure. I mean, the speed of this build-out is incredible.
It really is.
So today we're doing a deep dive into those HC 2025 announcements. We'll cover everything from their new chip plans and system architecture right through to how they're actually using that power for, real-world business transformation globally.
Exactly. And our job really is to guide you through this huge amount of information. We need to look past the technical jargon and the marketing spin to figure out what it all means strategically.
Right.
So the mission is to connect the dots between their hardware strategy, these new Ascend chips, the massive SuperPod systems, and their actual application plan, what they're calling digital intelligence transformation, using these global sample points.
Yeah, and we've got sources covering that pretty aggressive multi-year Ascend roadmap, the sheer scale of the SuperPods, which sounds almost physics-bending, and crucially, how these techs are being applied in big sectors like finance, education, telecom. So we're essentially trying to figure out not just what they're building, but maybe why they're building it this specific way.
Let's unpack that, starting with the basic challenge.
Yeah.
Raw computing power.
Okay.
So when you talk about training these next-gen large AI models, the need for compute is it's insatiable, right?
Absolutely.
And our sources openly admit a key constraint. There was a quote from a key figure saying they are still one generation behind the U.S. in single chips. Now, for anyone just looking at processor speed, that sounds like a huge disadvantage, maybe even game over.
It definitely sounds like that if you stick to the traditional view, yeah. But this is where the strategic pivot, I think, is quite clever, actually.
Okay.
The sources confirm they've decisively shifted focus. It's not about winning the single chip race anymore.
Instead, the whole strategy is about dominating at the system level.
Yeah.
They're using an approach Ren Zhengfei described as using mathematics to compensate for physics and group computing to compensate for single chips.
That's interesting. Mathematics to compensate for physics. It's a totally different way of thinking about it.
It is.
So instead of chasing one perfect processor, the whole thing is built around these Supernode plus cluster solutions. So for you listening, what makes a Supernode different from just like sticking a bunch of servers together?
That's a great question. It's really the difference between, say, a pile of bricks and a fully constructed building. A Supernode is this highly integrated high-speed computing module.
Okay.
Physically, yeah, it might be made of many processors, many machines.
Yeah.
But the mathematics part, the software, the interconnects, makes it function logically as one single unified machine.
Ah, so it acts like one brain.
Precisely. And that unity is critical for things like deep learning, reasoning, complex AI tasks. By pooling all those resources, this group computing, they boost the overall system efficiency. It lets them effectively work around the limits of any single chip inside.
That makes sense. So the weakness isn't the individual part, but maybe the gaps and delays when you try linking thousands of them the old way.
Exactly right. And to actually power this group computing idea, they unveiled a really, really aggressive multi-year hardware roadmap. They seem to be betting big on delivering consistently.
Okay, so what does that Ascend roadmap look like? Because they are committing to some pretty radical growth targets here, aren't they?
They laid out a very clear path. First, the Ascend 950 series. The 950 PR is slated for Q1 2026. then the 950 DT in Q4 2026.
Sure.
Then it moves up to the Ascend 960 series in Q4 2027, and looking further out, the 970 series in Q4 2028.
Wow.
And the core goal, the really ambitious part, is to essentially double their computing power every single year.
Doubling compute power annually? That makes Moore's Law look, well, slow.
Doesn't it just...
How are the sources suggesting they can actually sustain that? I mean, that feels like a massive R&D and manufacturing challenge.
Well, the sources point to two key things. First, that strategic shift to system architecture itself creates efficiency gains that feel like raw power increases.
Right. Better use of what you have.
Exactly. And second, they specifically mentioned developing their own proprietary, low-cost, high-bandwidth memory HBM.
Ah, okay. HBM is critical for AI chips.
Absolutely critical. And making it proprietary and low-cost isn't just about sourcing parts. It's about controlling and tailoring this vital high-demand component specifically for their Supernode design. It potentially lowers cost and speeds up the integration cycle needed to hit that yearly doubling target.
That proprietary HBM, that's a really crucial detail. Okay, but talking about scale, the new SuperPod products built using these chips, that's what really grabbed headlines, right? The Atlas 950 SuperPod managing, what, 8,192 cards?
Yes, 8,192. The scale is just staggering. And they were, let's say, very direct in their competitive talk.
How so?
They explicitly claimed this Atlas 950 system is designed to be stronger than NVIDIA's NVL 576 system.
Which isn't even out yet, right? That's expected in 2027.
Exactly. So they're not aiming to catch up. They're trying to leapfrog and set the next benchmark. And that commitment goes even further with the Atlas 960 SuperPod, planned for Q4 2027, scaling up to a massive 15,488 cards.
15,000 and nearly 16,000 cards in one system. Okay, that's group computing.
That's it.
But coordinating that many pieces, it must be incredibly complex. At that scale, surely the connection between them, the interconnect, becomes the biggest bottleneck, the biggest point of failure.
You've hit the nail on the head. It is the biggest challenge. And yes, that aggressive scale meant they basically had to invent a whole new way to manage that cluster nervous system.
And that's
the technological heart of it, Linku 2.0. It's their own self-developed interconnect protocol.
Linku 2.0.
Okay. Yeah. Think of it like this. If the Supernode is the brain cell, Linku is the incredibly fast, perfectly synchronized nervous system connecting thousands of them. Its whole purpose is to overcome those technical hurdles we're talking, ultra-low latency, keeping data perfectly consistent across all nodes that usually stop people from building stable clusters this big. It turns those 15,000 bits of silicon into one unified thinking machine.
Okay, Linku 2.0, the nervous system, which leads to, frankly, the biggest strategic surprise for me. They announced they're opening up the Linku 2.0 tech specification. Why on earth would they open source what sounds like their core competitive advantage?
It seems counterintuitive, doesn't it? But it looks like a strategic power play. It's aimed at defining the future standards for this kind of large-scale computing, not just selling their own closed boxes.
Trying to set the rules of the game.
Precisely. By open sourcing Linku 2.0, they're inviting the industry partners, maybe even competitors, to build compatible hardware and software. If the ecosystem adopts the Linku architecture,
then their Supernode plus cluster model becomes a default way to build these massive AI systems.
Exactly. It becomes the foundation. And commentary suggests this is the big signal, the move that shows they're shifting from just, replacing old tech to actually reconstructing the basic architecture for the whole industry in the AI era.
Right. That connects the hardware and the plumbing, let's call it. But raw power is just potential until it's used effectively, right?
Absolutely. Potential energy.
Which is why the next part of their announcements, the focus on applications, is so important. They announced over 30 of these global sample points for what they call digital intelligence transformation across different industries.
Yes. These sample points, Yangbud and Nadian, are absolutely key to the whole strategy. It's one thing to announce a 15,000 card cluster, right?
Yeah. Theory versus practice.
Exactly. It's another thing entirely to show a verifiable, reproducible blueprint for successfully deploying that power. These 30-plus examples covered government, education, medical, financial, power, lots of sectors. And the crucial part is they're open. Other global customers can actually go visit, see how it works, learn from them. It makes the theory real and importantly, replicable.
Proof of concept, but at serious scale. Okay, let's make it concrete. Can you give us maybe 3 specific examples of this applied intelligence they highlighted?
Sure. So in education, they pointed to the Shenzhen Cloud School. It's setting up a new model for what they call 1+N wisdom education communities, basically using tech to balance resources and improve teaching quality across multiple locations.
Okay, education. What else?
For tourism and resorts, they showcase Singapore's Sentosa Resort World. There, they use smart campus networks to integrate all the different services, ticketing, hotels, attractions, enhancing the whole digital experience for visitors.
Makes sense. And you mentioned finance earlier.
Yes, a big one. Pacific Insurance. They've established a large-scale setup based on this sample point architecture specifically for accelerating large AI model training and running inference, all tailored to the needs of the insurance industry.
That Pacific Insurance example is a perfect segue. The financial sector seems to be right at the forefront of this AI-driven structural change.
It really is. The dedicated financial summit at HC 2025 drilled down into 3 fundamental transformations happening right now because of AI.
Okay, what are they?
The first is a shift in the service model. Moving away from the old GUI graphical user interface, clicking buttons, searching menus, towards LUI, language user interface.
LUI, so talking to your bank.
Essentially, yes, but more proactive. LUI acts like a personalized AI assistant, anticipating what you might need based on conversation, not just waiting for commands.
Okay, less like a website, more like an expert advisor that talks back.
That's a good way to put it. The second shift is in collaboration. The old model was person plus tool, a human using software. The new model is shifting towards person plus AI colleague.
AI colleague.
Yeah. This creates what they called a one-person, one-team dynamic. The human focuses on the high-level strategy, the decisions, the relationships, while the AI colleague handles the heavy lifting, massive data analysis, drafting compliance reports, spotting risks in real time.
That could massively change productivity in fields like finance, where there's so much data and regulation.
Huge potential. And the third shift.
The third shift is in the infrastructure itself, moving from systems that were just compute-centric, mostly handling transactions, to systems that are based on general compute plus intelligent compute.
So needing infrastructure good at both normal operations and massive AI tasks.
Exactly. It requires specialized foundations optimized for both types of workloads running side by side efficiently. And to help financial institutions actually make that difficult transition, they launched a specific solution, didn't they? FAB, the Financial Intelligent Agent Accelerator.
That's right, FAB, or Fin Agent Booster. It's designed to tackle the complexity problem head-on. Banks, insurers, they can't afford, months and months of painful integration for AI projects.
Right, time is money, especially there.
So FAB is built to take the friction out of it, to get AI working in core business scenarios much faster.
And it has 3 core characteristics defining how it helps. Let's break this down.
Okay. The first is easy to use. This isn't just handing over a software platform. It comes with over 15 pre-built innovation scenario workflows and model rooms, all based on documented best practices from the financial industry. It's like a starter kit for common AI uses.
Okay, so it lowers the barrier to entry. What's the second characteristic? Ready to use. That sounds like it addresses the deep domain knowledge needed in finance.
It does, exactly. Ready to use means they've packed in over 150 financial model component packages, MCPs.
MCPs, like building blocks.
Think of them like pre-approved, industry-specific Lego bricks of financial knowledge. They contain regulatory rules, financial terms, common customer query patterns, all that domain expertise. So institutions can quickly assemble and train their AI agents without starting completely from scratch each time.
Got it. And the third one, smooth to use. That must be about performance and reliability, right? Critical for finance.
Absolutely, little critical. Smooth to use focuses on the hardcore engineering needed for high-volume customer-facing AI. It tackles tough problems like achieving over 90% accuracy in understanding what a customer wants, intent recognition, and delivering answers with millisecond-level latency.
Millisecond latency. Essential for core banking or trading.
Essential. If the AI agent is slow or unreliable, it's basically useless for real-time customer service or critical operations.
And they didn't just announce FAB, they backed it up by launching 3 big new global sample points with major financial players, right? Who are they working with to prove this out?
Yeah, 3 key examples were highlighted. For banking, it's the Bank of Communications Joint Innovation Display Center. They're focusing on strategy, talent development, alongside the AI applications.
Okay, but come.
For insurance, it's that Pacific Insurance Intelligent Computing Center again. which is significant because it's described as the first coordinated compute network storage cloud large-scale platform for the entire national insurance industry in China.
A national-level platform.
And in securities, high-frequency trading and all that.
That example is Guotai Junan Securities. They've been designated a lighthouse sample point for their digital intelligence upgrade. And notably, they showcased a fully self-developed, distributed core trading system running on this new architecture. Shows it can handle even the most demanding, sensitive financial workloads.
Okay, zooming out one last time. None of this hardware, the interconnects, the industry solutions, none of it really works without a big user base and software ecosystem, right?
Yeah.
That's where HarmonyOS comes in. Absolutely. That ecosystem piece is vital. The rapid growth they mentioned, HarmonyOS 5-based terminal devices surpassing 17 million units, provides the scale needed to justify this massive compute infrastructure investment.
And they're actively fueling that ecosystem.
Yes, they launched the Heavenly Work Plan Tiangong Jihua. It's a commitment of 1 billion RMB plus other resources, specifically aimed at supporting innovation within the HarmonyOS AI ecosystem. It's a direct investment in developers and future applications.
Which brings us back to that central theme the experts are picking up on. This whole strategy signals a shift. It's not just incremental upgrades anymore. It really is moving from replacing legacy systems to reconstructing basic architecture. And that reconstruction impacts everything general computing in finance and telecom just as much as the dedicated AI stuff.
That sums up the strategic scope perfectly. The entire narrative coming out of AC 2025 has changed. It's really not about single chip speeds anymore. The focus is squarely on how effectively these highly integrated, massively scalable cluster systems work, how the interconnect standards like Linku 2.0 get defined for those systems, and crucially, how the results are proven and made replicable through those 30-plus global sample points.
So for you listening, this blend of, well, radical hardware innovation and the mathematics compensating for physics bit combined with the proof points from real-world applications, it gives you a crucial map. You should now have a much clearer picture of the strategic blueprint shaping the next phase of global digital transformation, certainly from this perspective.
And perhaps the final thought to leave you with. If the success of this whole AI or intelligence era really depends on having accessible, unified, and truly scalable compute resources, then what's the long-term impact of this bold move to open source a critical piece of the puzzle like the Linku 2.0 interconnect? Does an open standard ultimately win out over proprietary ones when the scale required becomes this enormous? That's a really big question, and the answer might just define the competitive landscape for the rest of this decade.